Welcome to GDP's Game Engine Frameworks and Patterns 2019. My name is Felipe Bellini, and this is a video demonstration of the final for this course. This addresses the classes lectured by Michael Finney at Fanshawe College. This project is about 3D animation and scripting using Lua as the core components of the animation engine. The concepts shown in this project are also present in Project 2. Open the final solution in Visual Studio 2019 and run the game project. We should see a 3D scene of a tropical island with two flying pirate ships soaring above. This is our 3D scene where we can see both pirate ships soaring above. Let's begin showing the animation, and then we're going to look over the core engine of this. So first, press 3 for the first question. So the camera hovers beyond the attacker. Now the attacker should move by pressing button 4 to fly for about 10 seconds, and then the camera will go afterwards. We should always be seeing the attacker through the animation. Now pressing the key 5 on the keyboard, this should show the cannonballs flying around from one ship to the other. If I change to the debug mode, we can see there's a little green sphere flying around. Cannonballs are gray, so it's quite easy to see them once you run the game. So they're hitting the ship, and now in this moment we're having the second salvo when the defender starts moving, so it's trying to run away. So to soar above, and once that completes, we're going to move to the next. We can see the ease in and out in the scenes when the ships move around. So I'm pressing 6 on the keyboard. Now we're going to the next question. We have the camera shifting to the side while still maintaining both ships inside. Now the defender is trying to move away, while I'm using a mathematical curve for the attacker to hover around and try to follow it. Before diving into the code, there's a document called answers.docx that provides some explanations about what's going on in this final. So here's in red, and you can see some screenshots. So there are some notes that I left there for later use. So in this document I describe how my Lua animations are working with my engine. So this was already explained in Project 2's video, but I'll try to be brief here. So basically I have a bunch of Lua scripts that are generic in a way, and inside those Lua scripts I have parameters and variables that get replaced when we define the animations inside the XML file. So basically what I have is an XML file where I define the animations and the scripts, and I have the Lua scripts. I only have to use C++ when I need to provide the static functions for Lua to access. So I'll show you in the level file. So we can see there's a node called animations here, and the animations is a collection of scripts, Lua scripts. For instance, for question tree we have a move to, and then we have an orient to scripts in use. And for each script we have parameters that I was talking about earlier. These strings here are replaced. They are defined inside the Lua script, and they get replaced once the XML file is loaded. So what I have is a generic Lua script that becomes singular once it's loaded, because it gets a unique name, and with all its values changed during runtime. And once this script is consumed, when its lifespan has passed or it has completed its purpose, it calls dispose on itself. So I have a function in the C++ side that will register in Lua animator this script to be removed. So in the next frame, after this script is completed, it gets removed from the map of scripts. So here we have it, all the scripts being defined. We have a couple of extra features here, like a delay for an animation to start. We have the type of the animation, if it's parallel or serial, where parallel animations will cause all scripts to run independently, while if we had a serial type, the serial type will cause the scripts to run in a sequence. And also we have triggers here. For this final, I'm mostly using immediate. I don't have event-driven, but there's an example of event-driven triggers in the project. Basically the difference is that an immediate animation will start once it gets a request from the user or from the code, and the event-driven will only run once there is an event inside another animation. So I have a script that produces a trigger event, and that's not being used here, but there's one in the project. So we have answers for all the questions. Some of the questions have been broken into smaller sections, like question 4, 5, and 6 here, which have A, B, A, B, C, and so on. We have a definition of our game objects here also as well. So take a look at this file. This is one of the most important aspects of this Lua architecture that I developed. And all scripts look quite similar. They are always time-based, because I was telling about their lifespan, right? So they're calculated each frame. Right. And in the code we have some important points here. The classes that are most relevant to this final is the Lua animator, which is really a fork of Michael's Lua brain. It stores all the Lua scripts and processes them, and has the update function. There's a script class that I created for storing a script that's read from the XML. There's a game Lua animator which inherits from the Lua animator, and this class contains all the C static classes that the Lua scripts can bind to. There's user input, which ties the buttons that we're using in this final to the scripts. There's the word class. The word actually has the scripts for the buttons and so on. There's level loader, which takes the scripts from the level file and then loads them into a vector of scripts, of animations inside the level class. So these are the most important things there. I'm gonna show you the game Lua animator, which is a very important class here. So here we can see right off the methods that are static and that can be called by Lua. So I made a bunch of those here. So there are some helper methods, like for printing to the console, for instance, or for accessing GLM smooth step, or I don't know, other things like getting information from the game object, for instance. It's all here. There's other methods that handle the animations by type, like parallel or serial. There's methods for firing a single animation or for firing all animations at once. Like, for instance, this fire all animations is what I'm using in the project. But here in the final, I'm using fire animation because we need to bind the animations to keys. This is a singleton class, which uses some patterns that were taught in the beginning of the semester. So yeah, that's pretty much it. This concludes this presentation. For more information, contact Michael Finney at Fanshawe College and Felipe Bellini, the developer of this solution. Thank you.